Good morning, everyone. Today we're going to be talking about trigonometry. All right. Now, there's several different layers to this, and this is going to kind of be what we're focusing on the next 3 days. If you looked at the week 2 unit plan, um, this is something that a lot of you are probably going to have questions on. Just as those come up, make sure you let me know. All right. There's several different pieces to this, so this might be a little bit of a longer video. I apologize for that in advance. All right. The first thing that we're going to talk about is what is known as a reference angle. All right. The reference angle, it just depends what angle we're looking at. All right. It's never going to be the 90-degree angle in a right triangle. All right. But it could be either one of the two acute angles. All right. So in this picture below it, it could be A or it could be C. Either one of them. All right. Could be either one of those, and it just changes one of two things. All right, as you can see over the pictures on the left. All right. That's all a reference angle is. It's just whatever angle that we decide to look at to label the other sides of the triangle. All right. Now, we also have names for each one of those three sides. All right. First one we've already talked about a lot for yesterday in the Pythagorean theorem is the hypotenuse. Well, the hypotenuse is always across from 90, so the hypotenuse will always be here. All right. As you can see, the other ones, it's always that side across from 90. It doesn't matter if A is the reference angle or if C is the reference angle. The hypotenuse is always on the opposite side of B. That's never going to change. It's always going to be across from that 90-degree angle every single time. All right. Now, if we're looking at A as our reference angle, all right, the opposite side or the opposite leg is the side opposite A. All right, just like the hypotenuse is opposite the right angle, the opposite leg is opposite whatever our reference angle is. All right, so we're down here at A. The opposite side is the one on, well, the opposite side, the one that's not connected to A. All right. Likewise, the adjacent leg, all right, is the side that is adjacent to A. Adjacent just means right beside, or they share a side, they touch, whatever that is. Notice this side is one of the rays of angle A. So that side is adjacent because they share that segment or that ray. All right. The hypotenuse will never be the adjacent one. Even though it's part of that angle, hypotenuse dominates over adjacent. All right. So opposite's always opposite. Hypotenuse is always across from 90. Adjacent is always the side that makes the angle we're looking at. All right. But is not the hypotenuse. All right. If we switch to C, notice it's the same triangle. All right, we're just looking from a different angle. Now, the adjacent leg is BC. It's over here now because we switched what angle we were looking at. All right, our hypotenuse was still the same, but now our opposite leg switched with the adjacent leg because now A to B on this far side is opposite C. All right. That's why our reference angle is important, is because it can change which side's opposite and which side's adjacent. All right. Notice the hypotenuse doesn't change. All right. Now, you got about 5 examples down here. I'm going to leave 1, 2, and 3 for you. All right. But I am going to do A. Or if the reference angle is A right here. So here's my reference angle. I'm starting down there at A. My hypotenuse is always across from the right angle. So AC, that long slant, that's my hypotenuse. And I'm just going to label hypotenuse with an H. All right. Opposite angle A is what's on the complete other side. That would be C to B. All right. The other side that makes angle A is A to B. So this side right here is my adjacent. All right. If we switch to C, our new reference angle's here, and you'll find the opposite side, the adjacent side, and the hypotenuse in that triangle. All right, I'm going to leave that for you to do. The answers to all of those are right down here at the bottom of the page. All right, if you have questions about how they did all those, please let me know. All right, same thing with 4, 5, and 6 right here. I'm going to do number 4 with all of you. All right, reference angle for number 4 is T. So I'm starting up there. Hypotenuse is this side over here because it's across from the 9-degree angle. So that is T to R. All right. The opposite side from T is right here. That's G to R. Which means the adjacent side is that other side remaining that makes angle T, which would be TG or GT. All right. And that's all that's asking you to do. All right. But if we can't label these sides properly, we're not going to be able to do the next part. All right. So it's very important that you're able to label those sides as they need to be labeled. All right. Now, here's why that matters. All right. We're going to start talking about what is known as trigonometry. All right, I'm going to let you guys read. I'm kind of just going through, catch and highlight parts, so that way as you guys are reading through, you have time. There are 6 trig ratios, but for geometry, we only need to worry about 3 of them. All right, the first one is known as sine. All right, that's this box right here. Sine takes into account the opposite side and compares it to the hypotenuse. All right, so we take however long the opposite side was and put it over however long the hypotenuse is. All right, the next one we got is cosine. Cosine is almost the same thing as sine, except for it takes the adjacent side, however long it is, and divides by however long the hypotenuse is. All right, the last one we have is tangent. All right, tangent's the most different one. All right, it takes the opposite side and divides it by the adjacent side. All right, these are very important. All right, and we're going to be using them a lot. All right, there's more words down there. All right. One mnemonic device, or way to remember this, is you'll hear a lot of people go SOHCAHTOA, just meaning sine, opposite hypotenuse. Cosine is adjacent in hypotenuse. TOA, tangent is opposite over adjacent. All right? And I've been told there's a whole bunch of Chief SOHCAHTOA stories, if you want to look one of those up. The way I've always remembered it is I have a little bit of a different acronym, but because it's how I was taught it as a student, right? If we have OH for sine, so you got to remember sine was first, and you have cosine, that's second, so that's A and H, and tangent is opposite over adjacent, so you got to remember we went sine, cosine, tangent, but you have Old horses always have old apples. That was just the first way I was introduced to it, so it's what stuck in my head. All right? For a lot of people, what sticks, it's SOHCAHTOA. Sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite and adjacent. All right? As I said, if you want to search online for a story about SOHCAHTOA, please go ahead and do so. All right, this next page, all right, just has a whole lot of values. All right, and I realize this probably isn't going to make a whole lot of sense right now. All right, I'll show you on a calculator here in a second toward the end of the video where we find all these. All right, but basically what this is doing is I'm going to look here at 30 and 60 in particularly. All right. This is all from a calculator, and the decimals are what the calculator answer would give you. All right, so if we have 30, that's 30 degrees. That's what an angle would be. If I type in my calculator, sine, which is the sin button, and then I hit 30, it should equal probably 0.5. The rest of it, they just went out to the same number of decimal places on each one. All right. All right. Let's say I wanted to do cosine of 30. All right. If we go down and look at the table, that would be 0.866. So that is 0.866. All right. So you're going to have a lot of decimals. Guys, these aren't really nice numbers. All right. The reason we provided that table was just in case you don't have a calculator or can't find a good calculator. That way you could kind of approximate where those numbers were going to be. All right. So that's why that table's there. All right. Now, there's an example problem of how we're going to use it up there. I'm going to stop for a second, and I want to bring your attention right here. All right, a couple of you have already asked me about this, but what's degree mode in a calculator? All right, you're going to see this on almost everything that we do with trig the rest of this week, just so you have that reminder. All right, there's a couple different ways it works. I'm going to show you how I can find it on my iPad's calculator, so I'm going to leave our notes for a second. All right, and I have my calculator right here. All right, notice here's my sine. All right, first thing to notice, all right, it says RAD up in that top left-hand corner. All right. It says RAD up in that top left-hand corner. All right. Now, there's also a DEG button down on that bottom row of my calculator. So I'm going to tap on that. Notice up in the top left, it changes to DEG. Now my calculator is currently in degree mode. All right. So this is what it looked like first. If I hit the RAD button, I'll go back to that. All right. And now it says RAD up there, meaning radians. All right. Here's what happens if I forget to switch that. If I hit sine. Oh, nope. I got to delete that. All right. So I got to type in 30 first. I'm going to hit sine. All right. Notice, I get a negative 0.9. Well, if we go back to our notes, all right, we know sine of 30 should be 0.5 because it's right here. All right, that's the one we're looking for. All right, so let's go back real quick. All right, I'm going to clear that out. Up, add. Okay, and I'm going to change it to degrees. Now I'm going to type in 30. I'm going to hit sine. And it's not liking me today. Hold on, guys. All right, and there we go. All right. That was weird, guys. So make sure you have it not radians but degrees. Maybe I typed it in before I switched it. All right, so it says DEG up in the top. Go to 30. Then I hit sine, and I get 0.5. All right, just like I'm supposed to. So every single calculator you have, you will see a button like that. All right, if you're using more of a handheld calculator, you might have to go through and click on a mode button and then find it in your calculator settings. All right. If you can't figure out how to do it, let me know and show me a picture of what type of calculator you're trying to use, and I will help you find it. All right. But for most calculators, for most phone or iPad calculators, all you gotta do is you gotta find this button down here where it says DEG. Click on it. It'll change the degrees up top. All right. If it already says DEG at the top, you're good. Just start working on whatever you need to work on. All right. All right. Back to the notes then. All right. All right. Several steps to do this. First and foremost, draw a picture. If there's not already one, a lot of times there will already be a picture. All right. And you're going to label. All right. What we mean by label is type out the angle. All right. And the sides that we know. All right. So just make sure that that's what you're doing. All right. Then we need to find the hypotenuse, the opposite, and the adjacent. All right. We're going to do that on every single trig problem. All right. Then we're going to decide whether we need to use sine, cosine, or tangent. And we're going to plug the values in that we know. And then we're going to solve using algebra and then type it into a calculator. All right. So I know that's a lot of words. Here's how it looks as we're working out a problem. All right. Notice letter A down here. It's already drawn and it's labeled. We have 13 and 34. Those are the two sides that we know. All right. This little zero with the line through it is called theta. It's a Greek letter. It just stands for an angle. All right. So this is my reference angle. All right. Obviously, that was an awful H. That side's my hypotenuse. It's across from 90. If my reference angle's down on the left, 13 is opposite, 34 is adjacent. All right. If you remember, all right, opposite and adjacent, the only ratio that uses those two is tangent. All right. So we're going to use the tangent equation. All right. We don't know the angle, so it stays theta. The opposite side is 13, so the top is 13. The bottom is 34. All right. Now, we have this equation. All right. Now, we need to get theta by itself, meaning we need to move tangent. Well, tangent's not a number, so I can't just say, oh, divide by tangent on both sides, because it's not a number. All right, so we can't do that. So what we do instead is we do what they do right here. We say tangent to the -1 or inverse tangent. All right, that moves the tangent over here. and we get this line right here. All right. Then they type that into their calculator, so I'm going to go back to the calculator real quick. All right, it was 13 divided by 34. All right, and then we don't want tan, so we got to hit this little arrow to go up to the smaller ones above it. We want tan minus 1, and notice I get 20.92, which is the same thing they got right there, so that's their answer. All right, if you look at the other two, they're doing the same thing. One just uses cosine because they have the adjacent and hypotenuse sides. The other one uses sine because they have the opposite and hypotenuse sides. All right, I'm going to seal one of these down here. I'm going to leave you 8 and 9 to do. I'm going to work on 7 real quick with you all. All right, there's my reference angle. 12 is my hypotenuse. 9 is opposite. There's my adjacent. All right, opposite and hypotenuse. That ratio is sine equals opposite over hypotenuse. All right, from there, I'm plugging in my numbers. My angle always goes over here. So sine of, well, we don't know. So sine of theta equals opposite is 9, hypotenuse is 12. All right, now we move sine by doing sine minus 1 to the whole thing. So the angle equals sine to the minus 1 parentheses 9 over 12. Guys, always put that in parentheses. Just to remind you, when you type in your calculator, you need to do 9 divided by 12 first. All right. If I go to my calculator, let's clear that real quick. 9 over 12 is 0.75. I come over here. Sine negative 1. It's about 48.59. And once again, I think the answers are down here at the bottom. Notice that's exactly what we should have gotten. All right. Going to leave 8 and 9 for you guys to try, and if you have questions, let me know. All right. For A, B, and C, we're missing a side now. We're not missing an angle. Majority of this doesn't change. It just makes it a little bit, I actually think these are a little bit easier. All right. Notice we have 38 degrees. So my reference angle for this one's C. So hypotenuse, opposite, and adjacent. All right. We don't know the opposite side and we know the adjacent side. So I'm going to be using tangent, or opposite and adjacent here. We set it up. Notice the 38 goes on this side with tangent, and 12 goes on the bottom because it's adjacent, and the unknown is the opposite, so it's on top. All right. Now we want to get x by itself, so we multiply by 12 on both sides. Multiplying by 12. And then we can just type it into our calculator. All right, they did tangent to 38 first. So clear. 38 tangent times 12. 3.72. Oh. Did I type in something wrong? I don't think so. So 38 tangent oh yeah, 9.3. There we go. Huh, what did it do? How did I get it wrong the first time? Hold on, guys. I must have typed something wrong the first time. 38 tangent is that times 12. All right, yep. Guys, I'm sorry. I must type something in wrong the first time or hit the wrong button. All right, but that's the number that we get. All right, so if you're using a calculator, be patient. All right, I would try plugging it in 2 or 3 times to make sure that you didn't type it in wrong one of the times. All right, I am going to look through the next one. All right, notice opposite, hypotenuse, and adjacent. All right, so we're using sine. All right, key thing to notice on this setup. Since we don't know the hypotenuse, the variable's in the denominator. All right, so when we multiply, we don't multiply by 8 or divide by 8. We multiply by x on both sides. All right, now this time, sine of 16 is a number. It's that little decimal right there. All right, so we can divide by sine of the number on both sides. We work all that out. We get 29.02. All right, I'm going to check that on my calculator real quick because I don't know why it's acting so funny today. They took 8 and we divided by sine of 16. And that's still in radians, because that should be a positive. Hold on. Eight divided by, let's try parentheses, sine 16. No, that cleared it. 8 divided by parentheses 16 equals 29.02. So, guys, just make sure, I think that's the issue I've been having. All right, make sure you put the trig stuff in parentheses as you type it in. All right, I think that's the issue I've been having with my calculator. All right, make sure the trig stuff goes into parentheses just to be safe. All right, notice we got 29.02, what the answer was there. All right, I'm going to pick one more. All right, I'm going to do number 10. All right, I know x is my hypotenuse. This would be my opposite side. That would be adjacent from 39. So a and h is cosine. All right, so now I'm just going to plug numbers in. I got cosine of 39, because that's an angle, equals adjacent side I know is 19. The hypotenuse, I don't know it. It's x. So I multiply both sides by x. All right. Now this time I don't need to use inverse cosine because it's cosine times the angle. That's an actual number. So I can divide by cosine of 39. All right. Because I'm bringing the number with it on both sides. So I'm going to get x, or the hypotenuse, equals 19 divided by cosine of 39. I don't put that whole thing in parentheses because just so I remember to do that when I put it in my calculator, because obviously I've been forgetting. So we have 19 divided by parentheses cosine of 39 in parentheses equals 24.45 about. So make sure you're using your approximate signs. And notice that matches with what the answer is down there. All right, so once again, you have 2 there to try. All right, guys, I realize this is probably one of the more difficult things we've been doing this year, but it is very important. All right, you will use this in several other math classes. All right, or they will expand upon this in several other of your math classes. All right. Also, I can almost guarantee you if you take an ACT or Accuplacer, it will be on those tests as well, because it's a very commonly asked question. All right. Now, if you scroll down, all right, once again, here's another reminder that you have to be in degree mode. All right. And we also gave you all the ratios up here at the top on your homework assignment worksheet. All right. Number 1, you're using this triangle off to the left here. This is for number 1. All right. For example, opposite leg to angle A. So this is my reference angle. My opposite side would be over here, C to B, or B to C. So I find that one. That's 5. 1A is 5. All right. Sine ratio of angle C. So sine is opposite over hypotenuse. So I got to find the opposite side from angle C. That's A to B. The hypotenuse is A to C, so I need A to B over A to C. That's 8. B is 8. All right. Now, if you read the directions, notice it says you may use some of these numbers over here, 1 to 10 more than once. Some might not be used at all. All right. So the next set, 2 through 5. All right. Our reference angle for A is 30. All right, so this is my reference angle. It wants me to label the opposite, adjacent, and hypotenuse sides. Well, hypotenuse is always across from 90. Opposites opposite that angle. Adjacent's there with the angle. All right, now I just need to choose which trig ratio. Well, I have opposite sides. The hypotenuse, opposite over hypotenuse, is sine. All right, so those first problems on your homework, that's how you do them. The other page, which I did not copy into my notes, so I apologize for that. The other 2 pages are just simply what we did here in your notes, finding the unknown angles or finding the unknown sides. All right. Guys, as I said, this is a little bit tricky at first. All right. If you have questions, please ask them. I'll make sure I'm available. The other thing I want to do, at least for if you're in my class watching this video, because I've been sharing these with the other geometry classes too, if you're in my class and you don't like the grade that you got on an assignment last week, please make sure you do the corrections that I asked you to do, and that can bring your grade up. All right. Thank you guys for watching. I hope you are having a good quarantine so far. And let me know if you have any questions. All right. Thanks all. Have a good day.